Hello and welcome to day 4 of boot camp. Today we're going to go ahead and put everything together that we've talked to up to this point. We are going to look at connecting roots with zeros, with polynomial behaviors, with factoring, with synthetic, a little bit of everything all pushed together. Hopefully at this point of boot camp you are comfortable both with the vocabulary and you're comfortable with what we're doing. So today, basically about graphing, we're looking at the function f of x equals x times x minus 2 times x plus 1. I'll give you some time to go ahead and copy that down. While you guys are copying it down, here's the things we're going to want to do. Tell me everything you know. That pretty much summarizes what I want you guys to be able to do. In this case, it's specific. It tells us it wants the x-intercepts, the y-intercept. We're going to have to talk about end behavior here. Personally, as you guys are looking at this problem, one of the things that I really like already is that this is in factored form. Factored form gives me a lot of information for free already. Realize that we are talking about a polynomial here. We're no longer talking about quadratics, which is parabolas. Parabolas are part of polynomials, but in this case, we're going to have x cubed and x to the fourth. That means we're just going to have more roots. We can find roots by factoring, quadratic formula. We can find roots by factoring by grouping. We can find roots by sum and difference of cubes. We can find roots many different ways. So let's figure out what they've given us here. For starters, I've recognized that this is in factored form already. So if I want to know my x-intercepts, I know that my x-intercepts are roots. That is where the function equals 0 at. So that's the first thing that I'm going to do to find my roots. And I am not going to multiply all of these things together to factor it again. Realize it's in factored form. This is going to be x cubed. I know that it's going to be x cubed because x times x times x gives me x cubed. And that talks to me a little bit about how the end behavior is going to look, but I'll talk about that in just a second. Let's get our roots down first. We're going to use opposite x. X is going to equal negative 1. That's a root for us. We're going to use opposite x here. X equals 2. That's going to be a root for us. Lastly, don't forget about this factor of x. That's saying x equals 0. That means 0, 0 is also a root for us. Next up, I'm going to need my y-intercept. Well, hopefully it's obvious to you. We already have our y-intercept. This graph goes through the origin. It is both an x and a y-intercept. However, if you don't see that, the y-intercept is when x is equal to 0. So you can plug 0 in for all of these x's, and you'll see that it does equal 0 that way also. So we've taken care of actually all of our roots at this point. We've also taken care of the y-intercept. We actually have enough information here to go ahead and graph that polynomial. In this case, I need to remind you guys about polynomial end behavior. End behavior, once again, is what this thing looks like at the ends of the graph. I will look at the degree. The degree, if I were to multiply those together, it would give me 1x cubed. That means I have a degree of 3. And the leading coefficient is positive. A degree of 3 and a leading coefficient that's positive. My end behavior will be going up in quadrant 1 and down in quadrant 3. So, end behavior, again, a reminder of that if you haven't covered it or forgot about it, should match with everything we have discussed. We'll bring this bad boy down. And we're ready to rock and roll. Let's plot what we got. And let's see, I will use daisies today. Negative 1, 0 for a root, 2, 0 for a root, and 0, 0 for a root. That's all. We've taken care of our y-intercept and our x-intercepts. Again, the rules of the game say we can only go through the axes where we have coordinates. I know the ends of my graph. I know down in quadrant 3 I have to be going down. I know over in quadrant 1 I have to be going up. Now all you need to do is sketch one smooth, continuous curve between all your coordinates. And that's good enough to have it graphed. Match up everything you already know. Roots, y-intercepts, and end behaviors. But Mr. Wood, you're never nice enough to give us everything as factors. I know. How about this one? I've decided to give you another one that is in factor form because I want to talk about something specific here. It will actually show up today in our roller coaster problem. We're going to be working on class on the roller coaster problem. This idea of a double root is kind of really cool. I'll talk to you guys about that in just a sec. Before we get started on this, we're going to kind of get all of our information now. I do want to talk about what the degree is, because the most common mistake students would make on a problem like this is tell me that it's a degree 3. I'll give you guys a couple more seconds to copy this down. Again, that's f of x equals x plus 2 times x minus 2 times the quantity x minus 1 squared. And what I'm looking at on this problem is I want to know, oopsie, don't want to do that. I want to know what the degree is. Because I need to know the degree in order to figure out what my end behavior is. You probably already recognize that it's in factor form. It does have our roots already. So we're going to get that information down. Degrees. Well, Mr. Wood, on the last problem, he said x times x times x, instead it was x cubed. But you told me on this problem it's not x cubed. Why? Well, that's because this one is an x squared. So I actually have 2. I have an x squared there, and then I have an x and an x. So this time I actually have an x to the 4th. So now I have a degree of 4, and then my leading coefficient is positive again. So that tells me my end behavior is up and up, like a parabola. Positive is up. All right, roots. Negative 2, 0, opposite x here. Positive 2, 0, opposite x there. Roots here, that should be positive 1, 0. Okay? You said it was a degree of 4, but I only have 3 roots. Well, that's because I have a double root here. It's the exact same root twice, and I'll show you what happens in just a sec. Before we talk about that, let's go ahead and get our y-intercept. Our y-intercept is when x is equal to 0. X is equal to 0. That means f of x will equal 0 plus 2 times 0 minus 2 times 0 minus 1 squared, which is going to be 2 times negative 2. That will be the quantity of negative 1 squared, which is negative 1 times negative 1, which gives me positive 1. So that means my y-intercept will be at 0, negative 4. Okay? A lot of information given for free on this problem. Just want to hit graphing on that, so let's go ahead and use, we're using daisies. All right, negative 2, 0 is a root. Positive 2, 0 is a root. 1, 0 is a root. 0, negative 4 is my y-intercept. End behavior. I know it has to go up at this end, and it has to go up at this end. But as you guys are looking at this, it's going to be very hard to draw one smooth continuous curve through here And in fact, you guys could probably try it on your paper. And obeying the law that says we can only go through the axes at places we have roots or y-intercepts. Because, yeah, we're going to come down. We'll go through the y-intercept here. I'm going to come back up. And what would happen is, in the past, we would go through that point and come back down. But if I were to go through that point and come back down, that won't match my end behavior correctly. I know by what I already talked about, I've got to be going up on both ends. And that doesn't fit. And what was our other one? 1 and +2. Well, here's something special that happens. And I said that that's going to come back into play. The double root. The double root means it kind of goes up and down at that coordinate. Or, here's a better way to say it. It turns right there so it only touches the axes at that root. It goes from up. It's basically like a vertex. That root becomes a turning point. Now I can graph this thing and make it fit the way I want to. So, again, we have a double root. When we have double roots in our polynomial equations, it means that we have a turning point for that root. It's two roots. It's both an up and a down root, if that helps you. This graph is how it exists with 3 roots, but matches our end behavior correctly. Okay? So, go with what you know, which just means we're only allowed to go through that axis at roots, things we've discovered. We're only able to go through the y-axis at our y-intercepts. Double roots means it's a turning point on that graph. Okay? All right, next up. This is what we did yesterday. Very similar to last homework assignment. F of x equals 3x cubed plus 14x squared minus 20x minus 24. And I've told you that f of -6 is 0. Last night, for most of the homework assignment, all you had to do was find the other zeros, and then we left it at that. Today, you've got to find the other zeros, and we're going to sketch the graph. Tell me all you know. Put it all together. See how it all fits. Before I go any farther, I'm going to make myself an XY chart. I'm going to get down what they give me for free. Oops, that's my pen. What do they give me for free here? They gave me a root. -6, 0. They gave me a root for free. They also gave me the y-intercept for free. Y-intercept, 0, -24. What do I know without doing any work? Next thing they gave me for free, end behavior. This is a degree of 3. And the leading coefficient is positive, which means I know the behavior at the ends of the graph will be like that. Now I've got to figure out what else I can do, which really means find the rest of the roots, find the solution, solve the equation. How do I solve that equation? I'm glad you asked. We will use the 0 they gave us to divide out, and we're going to go from x cubed to x squared. How do we do that? Synthetically. -6 We've got 3, 14, negative 28, negative 24. And we had better get a 0, and we divided it out. It told us that over here. We're going to bring down the 3. 3 times negative 6, negative 18. 14 minus 18, negative 4. Negative 4 times negative 6 is positive 24. Negative 28 plus 24 is negative 4. Negative 4 times negative 6 is positive 24. I am shocked to see that when I divide out 0 synthetically, that I get 0 as a solution. Oh me, oh my. It's almost like that's supposed to happen. Now, I've taken out an x, a 0. So that means we've gone from 3x cubed plus 14x squared. We're going to go down to an x squared. I'm going to write that new expression, which is going to be 3x squared. I'm getting it right from these. Minus 4x minus 4. That's what happened when I synthetically divided it out. If it asked me to factor, and this problem didn't ask that, but if it asked me to factor it, then those are my factors so far. But this problem's asking me to graph it, which means I don't care what the factors are. We're going to use them. But I'm more concerned with where your roots are, when that equation equals 0. We now have a quadratic equation that we need to solve. Multiple methods to solve quadratic equations. Factor kind of seems to be the theme here. And if factoring doesn't work, use the quadratic formula. We've got 3 times negative 4 for negative 12, and then a negative 4. Set it up. That's going to be a 3x. That's going to be a 3x. Two numbers that multiply together to give me negative 12, and add this together to give me negative 4. Whew, thank goodness. Sure am glad this problem was factorable. I did not want to do the quadratic formula. Negative 6 times positive 2 is negative 12. Negative 6 plus 2 is negative 4. Looking at the right-hand side, 3x over 2, I cannot reduce. So that's a fraction. 3x over negative 6, I can reduce. I got a factor of 3. 3 goes into 3 once. 3 goes into negative 6, negative 2. That is x minus 2. Mr. Wood, I thought you said we weren't factoring. No, we're not. We're finding roots. Opposite x is a root. Opposite x here, that's 3x plus 2. Solving that, x equals negative 2/3. We've got a root at 2, 0. And we've got a root at negative 2/3, 0. In this case, I have 1, 2, 3 roots. The degree of 3, I will never have more roots than the degree I have. I might have less, which was the case of the last problem. We had a degree of 4 on that last problem, but only 3 roots. But I will never have more roots than I will have degrees. All right, I know the end behavior on this graph. I know my roots. I know my y-intercept. That's what I need to go ahead and sketch this thing. And I'm going to do that right now. And bring this bad boy down. You guys are probably getting dizzy as you watch this video. And I'm going to put it right up here. Let's plot what we got. Negative 6, 0. 2, 0. Negative 2/3 and 0. And then 0, negative 24. For me, I'm just going to write there. That's negative 24. It's not quite on this graph. Our end behavior, down in quadrant 3, up in quadrant 1. Down in quadrant 3, up in quadrant 1. Connect the dots. One smooth, continuous curve from left to right. Make sure you're only going through the axes at your roots. And here we go. Here we go. It's almost like it's a roller coaster. Here we go up the roller coaster, then we go down, then we go up. We'll be talking about that stuff later on today. So make sure you're ready. Again, make sure you get all the pieces and how they fit together. It's the stuff we've been practicing on all week. Factor to get your roots. Synthetic to get your roots. Divide out. Look for common factors. See how it all connects and fits together. That's what we're looking for here. I think this is the last one I'm doing. I think so. Yeah. Plenty of the zeros, x cubed, x minus x squared, minus 2x plus 8. Given that the factor is x minus 1, sketch the graph. At this point, there's the function, there's our factor. What do we know for free here? Let's get down what we know. If I can get this to work correctly. There we go. Get down what we know. First off, we do know the y-intercept. We're looking at, I'm sorry, I'm going a little fast here. I'll give you some time to copy that down. F of x equals x cubed minus x squared minus 2x plus 8. The given factor is x minus 1. Hopefully you're already thinking two things. Y-intercept given to me for free. Root given to me for free at opposite x. What else do I know? There's probably going to be two other more roots. I do know that this is a degree of 3, and it's it's odd, and it's positive. Once again, my end behavior is going to be up in quadrant 1 and down in quadrant 3. Next piece, I need to get the rest of my roots, because that's how I graph. They've given me the factor, which means I will synthetically divide out the root opposite x. Coefficients are 1, -1, -2, and 8. I had better get a 0 when I do this. 1. 1 times 1 is 1. -1 plus 1 is 0. 0 times 1 is 1. -2 plus 1 is -1. -1 times, did I make a mistake here? Positive 1 is what I need to divide out. 1, -1, -2, positive 8. I'm in trouble, I think. 0, 1, -2. -1. That's not right. Hold on, I'm going to pause that video. I'll be right back. Okay, I'm back. Let me apologize. I gave you guys a bad problem. So here's what we're going to do with that problem. We're going to throw it out. So if you have that problem, x minus 1 was not a factor of that problem. So go ahead and put a big X through that on your paper. I want to see that it's thrown out. Tomorrow, when I check your notes, I'm actually going to want to see that big X for that problem on your paper. Sorry about that. Hope we didn't waste too much of your time. This is the last problem we are going to do here. Once again, it's just putting it all together. We're going to look at the function f of x equals x cubed plus 6x squared plus 3x minus 10. And I've given you another 0 here. It's x equals -5. Okay? Putting it all together there is what we want to do. We want to figure out what we have for free. Again, as you're copying this down, you should agree with me that this is going to be a odd degree and the end behavior is going to be up in quadrant 1 and down in quadrant 3. They've given me a root already, so I better be able to synthetically divide it out correctly and get a 0. Oh dear God, I hope so on this problem after that last one. All right, I'm going to get an XY chart, get down what they gave me for free. Before I get any farther, I've got a couple pieces. They've given me a root at negative 5, 0, and they've given me a y-intercept at 0, negative 10. From here, I'm going to synthetically divide things out. 1, 6, 3, negative 10. And I better get a 0. Really, I better get a 0. Bring down the 1. 1 times negative 5. Negative 5. 6 minus 5 is 1. 1 times negative 5. Negative 5. 3 minus 5. Negative 2. Negative 2 times negative 5. Thank goodness. Negative 10 plus positive 10 is 0. We've taken out that root. We had x cubed originally. Reminder, x cubed talks about our end behavior. It's positive and it's odd. That's what it's going to look like for end behavior. And I've gone from x cubed down here to now in x squared plus x minus 2. We're looking for roots. We need to factor. It's a negative 2, a positive 1, x over. Some of you guys are getting pretty good at this. You can do it in your head. Hopefully you'll agree with me. Hopefully I do it right. That's a positive 2 and a negative 1. Factors. X plus 2, x minus 1. Again, we're looking for roots, so we set that equation equal to 0. And that gives me opposite x, opposite x. Those are my other two roots, 1 and 0, negative 2 and 0. That's the information I need. Y-intercept, x-intercepts, end behavior. Put it all together. Oh, didn't want to do that. And should be able to graph this bad boy. Let's see. This time we're going to use little targets. Negative 2, a root. 1, a root. 0, negative 10, and negative 5, 0. Negative 5, 0, a root. And down here, that's actually negative 10. End behavior. Down at one end, up on the other. We've got to be down at this end, up at this end. One smooth, continuous curve, only going through our roots and our y-intercepts. And there we go. That's it. Make sure you're okay with how it all goes together. All right. I will see you guys tomorrow.